Hey guys, what's up? So today we are going to be solving Kth Missing Positive Number. So let's look at the problem statement first. It says you are given an array of positive integer which are sorted in strictly increasing order, and some integer k. Return the kth positive integer that is missing from the array. So let's first understand the problem. So say for example, let's say we have this array. We are given this array instead of the one over here, and the value of k is 2. So this is the array that is in increasing order. So you could say 1, 2, 3, 4, 7, 11. Now you have to find the second missing number. So that would actually be, we have 1 over here, we have 2 over here, we have 3 over here. Then we have 4. The 5 is not present. So 5 is not present. So 5 is the first missing number. And then we do not have a 6. So 6 is the second missing number, right? So the answer would be 6 for this array. So let's just check it. Right, so yeah, so answer would be 6. Now how do you go about solving this problem? So this problem could easily be done using a for loop. So this question could easily be done like this. So we could run a for loop from 1 to 1000. We are running it until 1000 because we know ith element is less than or equal to 1000, so it would actually be 1001, right? And then what we do is if I is not present in that array, this array, we reduce the value of k, and when k is equals to 0, then we simply return I minus 1. So what is happening is, for say first iteration, let's take this example. What happens is i's value is 1. So I is not present in array. So I is not present in this array. Then k becomes 4. Right, now the value of k has become 4. Right, 2 is present. So we'll just move to another iteration. 3 is present, 4 is present. Now comes 5. 5 is not present in this array. So k's value again gets reduced and it becomes 3. After 5, 6 is not present. So k's value becomes 2. 7 is present. Right, so nothing happens to the k's value. 8 is not present. So k's value become 1. And then again 9 is not present. So k's value becomes 0. Right, so now that the k's value is 0, from here we move into the next step. Now, so this k became 0 when I was equals to 9. Now when we move forward, I is equals to 10 and k is equals to 0. So we just simply return I minus 1. So let's check if this works. So let's just check if this works. Yeah, it works. So, but this solution is actually, in worst case, it's an O(n) square solution. Because you're also having this check over here, which is O(n), and this already is O(n), right? So it's O(n) square. Now let's find some optimized solution. So what do we have over here is that we have an array of positive integers which are sorted in increasing order. So that the array is sorted, can we actually do a binary search over here? Is there a possibility that binary search could be done over here? So let's look at two ways to do it. Either we could run a loop, and again we can binary search that number over here. Now let's try and finding some other way over here. So what we see is, if we have an array like this, 4, 5, and then we have 7, and then we have 11, and say k's value is equals to 2. So you know the answer would be 6 over here, right? 5 is the first missing number and 6 is the second missing number. So answer would be 2 over here. So after this, what we actually do is we try to find a relationship. So let's see what would be our mid over here. So start would be 0, end would be length of nums, which is 1, 2, 3, 4, 5, 6. So mid would actually be 0, 1, 2, 3. This would be our mid. So we would simply see that if at mid, where the mid pointer is pointing, if the array's value is equals to mid plus 1, right? So there are no missing number before that. So let me just show you what I mean. So we'll first start the while loop, which is less than equal to n. We'll calculate mid. So it would be n minus start, right? So we have let's calculate the missing numbers. So what are the number of missing numbers until this point? Let's forget this array for a moment. What are the missing numbers until this point? So there are no missing numbers. Why are there no missing numbers? Because the array's value at mid minus mid plus 1, it should be this, is actually 0. So if you check over here, array mid is 0, 1, 2, 3, 3, and the value over here would be 4. And because this m's value is 3, 3 plus 1 is 4, so missing numbers is 0. Now let's look at this. Now let's imagine you then move the mid over here. If the mid is moved over here, the mid's value is actually, m's value here is 4, and array of m's value is 7. So it would be 7 minus 4 plus 1. So what happens over here is we have two missing numbers. This gives us two missing numbers. So are there two missing numbers before this index? Yes, there are, which are 5 and 6. Right. So let's see how we could code it up. So if missing numbers is actually less than k, which is the total number of missing numbers we actually need to find. So what could we do? So let's go back to the array. So array was 1, 2, 3, 4, and then we had 7 and 11, right? It was over here, and k's value was 2. So we'll write this case later, but if to mid plus 1. So start would come to mid plus 1. And then if you look at the problem here, then start, and this is yan, then 4, 5. So it would become 4, 4, 0, 1, 2, 3, 4. So mid becomes this. So mid and start becomes the same index. And then you get missing numbers value as 2. Numbers value as 2. So if that happens, you make and as mid. So everyone is pointing over here. So this becomes this, and becomes mid, right? Once and becomes mid, then a mid is actually this number over here, right? And then what will happen is, and there could break out, your start should be less than it. So the value of start is 0, 1, 2, 3, 4. So we will just run start plus 4, 5, 6. Yeah. So now let's understand the problem. What we did over here is we first calculate the number of missing numbers by this. So say initially start pointer was here, the end pointer was here, and 0, 1, 2, 3, and the middle pointer was here. So was missing numbers less than k? So missing numbers for this mid position is 0, and are they less than k? Yes, they are. So start becomes this point, right? Start gets to mid plus 1. Start gets to mid plus 1, and then mid is calculated again. So it is 4 plus 5 minus 4 by 2, which is again equals to 4. So mid becomes this same point where start is pointing out, right? And let's say I mid is 7, and it's 4, 5, 2. The missing numbers is 2 values 2, and k's value is also 2. So is it less than k? No. Is it the other case? Yeah. So end would become end would point where mid is pointing. So at the same location over here. Now because end and start are pointing at the same point, the loop would break out. Your start is no more lesser than end. So let's see what is the value of start. Start's value is 0, 1, 2, 3, 4. Yeah. And what is the case value 2? If we add both of these, we actually get 6. And should 6 be the answer of this? Let's check out. Case value should be 2. Let's see if it works. So it should actually here the array. Yeah, let's try and submit it. Yeah, so this is the way you could do it using binary search and log in time.